the reality is that making adapters, running nodes, running the contracts, kind of all of this eventually fits together in a way where the people making the adapters, the people running the nodes, have the right economic incentive from the point of view of all the people consuming these resources. And that's the dynamic that we really want to achieve. So the fundamental problem is that all these blockchain environments where we build these highly reliable contracts that are going to change the way people do commerce and they're going to create new trust relationships, those environments can't speak with external systems. Due to the way that mining occurs around the blocks and their transactions, there's actually no secure way to get the same miner set that you have to acquire external data. This creates something known as the Oracle problem or the smart contract connectivity problem. And what this effectively means is that you can write a contract about data in a chain, which is basically token data, ledger data, which natively lives in that environment. You can't write a contract about any external event. So this excludes market events, IoT events. It excludes an entire world of events. You also can't generate events from contracts. And this is, in our opinion, what has kept contracts limited to only token movement, right? So the idea that contracts will continue to be limited to only token movement is a problematic idea for us, not because token movement is a bad thing, it's a good thing. It's only a small percentage of what we think all of this can actually do. Moving around tokenized assets and keeping that data natively on the same ledger where the logic lives is a great thing, and it's created a lot of great opportunities, and it's going to continue to create all kinds of good ownership and trust relationships with people. But the reality is that if you look at the digital world that the blockchain world is trying to kind of eat up and replace, you see that the majority of contracts are not about mere data ownership or ownership movement, they're about events. So that the majority of contracts, digital contracts out in the world, are about market events or IoT events or ad marketplace, advertising events, or it's all very events based. Now, if we solve this problem, I think just to put it in historical context, I think what this will look is it'll look like a step function in the value that and the usefulness that people can provide with these systems. I mean, we've seen a few step functions like this before, where basically in the 13th, 14th time frame, we went from Bitcoin multi-sig as the only smart contract at all to some version of other smart contracts in the form of these protocol contracts, these opcode-based contracts in 13 and 14, where you had to spend 6 months talking to protocol developers to make a new opcode for you to build a contract. Fundamentally speaking, I mean, it's a very relatively straightforward approach where you need a secure and provable way to create decentralization for the Oracle mechanism. The manner in which we approach creating that is basically this service agreement model where an Oracle contract receives a request from a user contract and then makes a commitment. So the key idea here is that you can have oracles make very specific commitments about, I will send you this data at this frequency, I won't deviate this much from other node operators, I'll do it this often for this time period, and I'm putting up a certain amount of stake to guarantee that I'll do that, right? So it's on a case-by-case basis definition of an economic guarantee that the data your contract's relying on will be received. Once you're able to arrive at a certain level of decentralization at this second level out from the core computations kind of decentralization, which once you're able to have this type of security at the essentially the middleware level, then you can have it at the data level. So then you can have multiple Oracle nodes, and then you can have multiple data providers if you want. This is once again about choice, and it's about developers being able to decide, right now I have $1 million in my market, and I want 3 nodes. Tomorrow I have 10 million, I want 15 nodes. And I want this many number of data sources. So the goal for us is to create highly secure, also easily usable, the way Ethereum made it easy usable to make contracts, resource for people to build these events-driven next-generation contracts. Now, one thing that I found is always very illustrative as examples. This is essentially a decentralized derivative, so it's a decentralized finance product that instead of being triggered by one data feed through one node, which the attack vector is relatively clear. You can have multiple node operators for multiple data sources acquiring data, triggering the contract, creating a level of security and reliability that you simply can't get with a single node operator and a single data source, no matter how much you want to trust or like that node operator or that data source. I mean, this is the fundamental kind of idea behind our model, and then, or our spaces model. And then you need to do payment. So oracles also enable a large amount of payment events, which in the case of the types of contracts we're working on is rather useful. So I think at this event, once again, it's probably appropriate to look at how can we all work together to make something like this happen. I'm already assuming we want this to happen, clearly I'm very biased, but assuming other people think the same way, how does something like this happen? These adapters are written right now by community members. A lot of times they give things back to the community, which in my experience is how open source works, and how we're at some point soon I think we're going to see more and more people using this, and more people putting back useful adapters into larger circulation, and then those adapters being security audited, so that you have a full end-to-end system that you can believe is secure, right? The only thing you probably won't know about is the data source, and then once the value secured by that data source becomes large enough, then they become compelled to become more open. But until then, it's not likely. But at the very least, what we can do is we can have full transparency and security at the contract execution level and at all the levels of what an oracle does, right? This is one example. It's somebody coded up a Halo 5 adapter, so if you wanted to make some prediction market about an esports event, somebody who's probably working on a project related to this made this adapter, put it out there for other people to use, and I think really this is how a lot of this is supposed to and is going to work. Is that people are going, and this one's, for example, under the MIT license, and it's clearly stated there. I think it's a logical evolution that if we want a solution like this, we should all come together and in an open source kind of manner build one. Now, another example of people contributing to this is folks at Honeycomb. So what they're making is a collection of data feeds that can be used by node operators. And I think you're starting to see that there's a few places where folks can participate in creating security here. But the reality is that making adapters, running nodes, running the contracts, kind of all of this eventually fits together in a way where the people making the adapters, the people running the nodes, have the right economic incentive from the point of view of all the people consuming these resources. And that's the dynamic that we really want to achieve. From our point of view, what we do in this process is we create a framework that allows all the transactions generated from this to create a large amount of highly secure data. That highly secure data is then floated to users. It's also augmented by all kinds of things like certification, initially from us and sometimes soon from other security auditors and penetration testing firms.